Good morning, everyone. I'm Harsh, and I work in desktop application development for Mindfire solution. And today I'll be discussing all about WPF and XAML. So I'll be introducing you all people to what WPF is and what XAML is. So just a quick question. How many of you are already familiar with WPF or XAML? None. That makes easy for me. So this is the agenda. First we'll see what is WPF. Then we'll have a look into the past to compare the things. Then we'll look into the features of the WPF. We'll understand the architecture, then types of application which we can build using WPF. Then a little knowledge about XAML, and we'll get to know where is it today, the scope of XAML, how it would help us, and then ultimately when to use WPF. So that would be our final goal, so that once a requirement comes to us, we are able to decide, like, this is the technology that I should use. So what is WPF? As written here, as written in MSDN everywhere, that it is a next generation presentation system. So why this next generation over here? All of us see Hollywood movies, right? And we have been seeing these Bond movies where James Bond touches the screen and it all works. In the era when there was no hope of touch screen. So that came into picture later. But the applications which we create using the old technologies doesn't support such kind of graphics or such kind of scope visually or performance-wise. So WPF is a way for us to create those kind of application. That will really, that would have stunning UIs, that would have very good performance. So if we see what actually WPF is in terms of its core part, so it is just a graphics rendering engine. So what is meant by graphics rendering engine? It simply paints the pixels on the monitor. Okay. So if you display anything, it would just paint the pixels and it would generate the UI, it would generate the graphics, it would render the graphics for you. It is a framework, it is an independent framework. It can be used by designers, it can be used by developers. That's the most important part of WPF. So it is now we know that it is a framework and it is a graphic rendering engine. So now this is a framework, and the best part is this is not isolated. Like, WPF is a framework which is not something that Microsoft has created separately and kept it aside and you have to use WPF framework. It comes along with the .NET framework. So you get to use all the goodness of of .NET framework along with WPF. So you can use WCF, Workflow Foundation, everything that works great with, along with WPF. So you have the power of existing .NET framework, and you take the power of WPF, and you merge, you have great applications. Now, flashback, look into the past. So where it all started, this GDI and User32 was introduced in 1985 with Windows 1.0. So why should I discuss about GDI and User32? This is because Windows Form application, which we currently use, mostly we use Windows Forms application. And those Windows Form applications are based on these two, GDI Plus and User32. For graphics, it uses GDI Plus, and for software rendering, it uses User32. Now let's think, like, GDI Plus and User32 were created 20 years back, and there were very little changes then after. So still we are using the same technology to create the Windows applications. and we won't have very good results. We have normal application. We have business line application, which have very which have very good functionalities. But when you see it as a point of view of user experience, it lacks. So GDI and user32 are used for WinForms. Then later on, DirectX came into the picture in 1995. So what is DirectX? DirectX is again a graphics rendering engine. It's a very powerful engine, and DirectX was one of the most important part of Microsoft for creating these graphics and all, games, graphics. So when DirectX matured, with DirectX 9 and onwards, it had its own frameworks, XNA framework, which is currently used to create great games for Xbox and all. So the games which you play on Windows or Xbox are from DirectX. No, so why DirectX? Why we are discussing DirectX? Because WPF at its core, at its base, uses DirectX, not GDI. I'll tell the difference why GDI is not as helpful as DirectX. So next, when in 2001, WPF, which was then known as Avalon, was thought of, and it was the Microsoft people started working on it. They saw the scope of what it could do, and they started with it. And in 2003, with .NET Framework 3.0, WPF 3.0 was introduced. So that's where it started, and I'll tell you more about. So what are the features of WPF? First one being broad integration. So what does it mean? So we have 2D, we have 3D, we have video, speech, animation, all in one hood. So what does it mean? Why? I mean, previously when we created, if you want to create anything in using WinForm, if you want to create a 2D or a 3D, or you want to integrate some video, you'll have, for each you'll have to have some third party or some another tool which you need to use it, which you need to integrate to make use of 2D and 3D. And it might not be as good as how it is in WPF. But in WPF, it all comes in one package. You get to use everything, and the use is quite easy than handling it separately. Because handling it separately, you would need different developers of the expertise, of different expertise. But here, all comes in one hood. Again, it has a very effective data binding. So we are coming to this is the programming part of benefit, which WPF has. The data binding part is very good. I mean, you have these dependency properties in WPF, and these properties get directly bound with the UI. You can bind it with data grid, label, any UI. You can have two-way, one-way bindings, and the bindings are they work superb. But you need very deep knowledge to implement it properly. We won't be going very deep into data binding today, so. Now, one of the most important feature of WPF. WPF is resolution independent. What do I mean when I say it is resolution independent? If anyone has worked in a WinForm or desktop application, he must be knowing the pain of creating an application and targeting it for all the resolutions. Because when we create an application in Windows for a desktop application, we have a certain resolution in mind. That on a certain resolution in which I'm creating, it would appear as this. And if I decrease the resolution, so if I decrease the resolution, the size of the form would increase, because it's all based on pixels. And when a button is of this much pixel, and I reduce the number of pixels, the button size would increase. And similarly, if I use a higher resolution, which is very common nowadays, because we use very high resolution monitors, we use great, LED, LCD screens. So in those situations, the whole form shrinks. The application would become tiny. So this was an issue with old WinForm application. But WPF is completely resolution independent. So what does it mean? That if you create a WPF application on a certain resolution, it would automatically resize itself. I mean, resize in the sense, if a 1-inch button appears of a certain size on a particular screen, it would appear of the same size on a bigger resolution, on a smaller resolution. The size won't change. It is, again, it's scalable. So if you create a window, you stretch it, the size and all, because it's based on all layouts, so it scales itself. I mean, this feature we did not have in Windows WinForms. We had to create these panels and all. We need to go through all the pains to create these panels and maybe use third-party tools to get them. So all because it uses vector graphics. Then how it manages that resolution independence? So it uses device independent unit, which is 1/96 of an inch. This is standard for WPF. So what does this mean? This means that to represent 1 inch, it would take 96 pixels. Okay. So how does this makes it resolution independent? So let's take a physical unit would be equal to device independent unit into system DPI, dots per inch. So that means in a system which has 96 DPI, which is standard, so 96 DPI, and we have the device independent unit as 1/96. So the physical unit would be 1. So that means 96 into 1. So 1 inch would be used, 96 pixels would be used here to create 1 inch of anything. And suppose the DPI increases. Okay. So if the DPI increases, the physical unit would also increase. Suppose the DPI is something 120, and the physical unit is 1/96 into 120, which comes around 1.25. So one physical unit would be 1.25. So now 1 inch would be 96 into 1.25 or 120 or around something. So now 120 pixels would be used to show that 1 inch button. So you see now how it manages the size on different resolution. If we would have been using WinForms, it would have taken just that 96 pixel on this 96 DPI screen, and again 96 pixel to display that same button on that 120 DPI screen. So this is how resolution independence works. Next important aspect is hardware acceleration. We have smooth graphics and a very better performance UI. You all must have used Windows 7, Windows 8. You must have seen the Office 2010, how it changed the whole ribbon concept. It's all based on WPF, and how it works so smoothly despite of such rich graphics. Because UI rendering is done by GPU. So we have two things: central processing unit and graphics processing unit. So using WPF, the hardware acceleration works, and the whole UI processing is done through the GPU. So when I run my application, the application splits the load and tells the GPU, you handle my UI, tells the CPU, you handle my software rendering, and it will perform definitely in a better way. Whereas if we go in normal applications, in WinForm, everything that GDI and DirectX concept comes now. GDI works on just the CPU. So if you want to paint a button, it would ask the CPU, paint it for me. But if you ask, I mean, if you are going through DirectX, Direct 3D, it would ask the video card to paint this button for me. So if we use this, I mean, we have very high-end graphics card being used today in our normal machines, but we can't take the advantage unless we use such kind of technologies. So now, since the GPU and CPU are separated, it works great, and the performance is automatically increased. It's better. Now, it has a software fallback for all rendering. What does that mean? Is yeah. GDI plus errors. Okay. Okay, so his question is, when he gets his GDI plus errors, is it related to CPU? It might be related to anything, it might be a bug, it might be anything which has crashed in the process, but the processing which is done would be through CPU, so not from the card. So whatever graphics card you put on your system, the ultimate processing of the GDI would be done through CPU. Yeah, so we were at, it has software fallback for all rendering. So it means that if I have a rich WPF application, it would work great on a system having a very good video card, having high-end hardware. But what if I switch it onto a Windows XP, a legacy machine having a limited hardware support? So what would it do? It would show the same UI. It would render the same kind of graphics. It would show the same kind of layout. Everything would be same. The only difference would be it would fall back to the older part. It would again process it through the CPU and not through the GPU. So that would obviously make the application slow. It would, the application may or may not run very smooth, but the application would run as desired. Okay, so again, a very new thing for Windows application development, which was introduced in WPF. In Windows application, we never had this concept of separate UI. The whole UI was the main code. If you drag a button, drop it on the form, a VB or C# code would be generated in behind. So it was all maintained through that. Now, like the web, WPF also has this declarative programming, which it uses XAML, extensible application markup language, for its generating its UI. So how does that help? First of all, UI is separated from code. Win-win situation for everyone. Developers get to have a clear separation between code and the UI. Secondly, designers are now collaborated with the developers. We have this excellent tools which are available, like expression blend, which can be used by designers to create great XAML. You can create great designs using expression blend. Then you'll finally, the designer creates a design. He submits that, okay, this is my design. So finally, the output would be a XAML file. You get that XAML, integrate it with your code, and you're done. So we have stunning UIs with the help of expression blend and XAML. Again, XAML also supports very good data binding. Okay. Rich composition and customization. So as I said, like XAML is a declarative language. So you must all have used HTML. So similarly in XAML, we have no bounds. We can create anything out of anything. You want a combo box having image in it, also playing a video in it. I mean, this sounds crazy, but I mean, imagine, this is just an example that you can have a combo box having image, having video, having audio, anything playing in it. So this is just a hypothetical situation, but if we use it efficiently in the practical scenario, we can have great controls. So one thing which comes over here is, I mean, nothing is impossible in WPF. If you can think of something like, I can think of X control, I can make it. I need some knowledge, but I can do it. Because there is no fixed control system, there's no bounds, you can create anything. Now, the deployment part is very simple. It's completely same as the WinForm application. The click once works here, Windows installer works here. So now taking a look at the architecture of WPF. So at the top layer we have the managed layer, which contains of Windows base class, presentation framework, and presentation core. So these are all written in C#. We use this managed layer, we use this layer, and we get our results. So Windows base is which we use for all kinds of properties and all functionalities related to the software part. Everything is handled in Windows base.dll. Then we communicate with presentation framework to get all the elements, all the UI, everything related to the UI you get in presentation framework. So basically these two are the most important DLLs which we interact with. Then comes the unmanaged layer. So this managed layer interacts with unmanaged layer, which is MIL core and Windows Codex. So these, I mean, you don't have to worry about these unmanaged layer are responsible for giving you the output like resolution independent and all, and you don't have to worry about a thing because it is handled internally. Then these unmanaged layer then interact with the operating system core and elements like CLR, Direct 3D. Then again at the base, again comes the user 32. User 32 again is used in WPF, but we never directly interact with it. It's handled internally. GDI is rarely used. That's maybe for fallback. And the device drivers. So now when we have sufficient knowledge about what is WPF, let's look at what is XAML. So as I said, extensible application markup language. It is a declarative programming language. It's very similar to what we do in HTML or any such declarative language. XML, it's all based on XML. So it integrates graphics, design, and development process. So as I said, XAML would be used by the designers as well. It would be used by the developers as well. So for any kind of designs, any kind of UI, you just get a XAML, you integrate it, you get great application. So it's a concise way to represent UI. Enable separation of UI from code. So let's see what is the scope of XAML right now. Okay. XAML was created as a part of WPF to support WPF, to give that UI separation for WPF. But let's see down the line in these past 10 years where XAML is. And I must say that XAML in itself is a completely very big part. I mean, independent of WPF, it's huge. So in current scenario, in today's date, when we see, if you want to create a desktop application, you might need C++, C#, or VB.NET, .NET framework knowledge, and XAML for the UI part. If you go for ASP.NET, you'll need HTML for designing. Again, same languages for coding and the .NET part. For phone development, again we need XAML with the managed API. Windows Store, those who have seen, those who have worked in Windows 8 application, they are very much familiar with what is the power of XAML in Windows Store applications. All these Metro apps, all these great UI is created all in XAML. So, all this means is if you are knowing XAML, if you are in current time, if you are spending your time, if you are investing in learning XAML, you are there to stay in the market, because this is the future. Windows is focusing entirely on Windows 8. Windows 8 applications in turn are based on XAML. So, talking about Windows 8. So, since Windows 8 introduced Metro apps, Windows Store apps, so we must be thinking, why do we need desktop applications now? Since Windows 8 is there, but still there are a lot of users using Windows XP, Windows 7 and all. So for them, using legacy system and all, and still supporting Windows 8, and who wants to support the future versions, WPF is the best thing right now, because WinForms won't be as much good as WPF would be. Okay. So when to use WPF? I mean, I must have made this part pretty clear in the discussion itself. So first is a rich UI application. If you want to create great UI with better performance, go for WPF. Then desktop applications. All kind of desktop applications can be created. We can also create page-based applications. Touch, which is the future. I mean, nowadays, previously we had touch mobiles, then came tablets, and now it has all started with the laptops, the desktops, and it's pretty much spread. And if you know, this would be the future of the technology. So, touch-based application won't be as good in WinForms as we may expect in WPF. And then again, when to use. So only restriction which I see when not to use WPF is when you know that you have a limited hardware capability. Okay, you want to run your application on Windows 98, don't go for WPF. You want to run your application on Windows XP with limited resources, but a very high-end application, don't go for WPF. In any other case, you can simply go for WPF in today's date. So, any questions? So, that's all then. Thank you.